Hi there PLC software developers. In the last part we were discussing structures and functions, which helped us to write and modularize our first programs. In this part we will start to look into the object-oriented programming parts of structured text and IEC 61131-3, called function blocks. And I think it's here things are really starting to get fun. For those that are Java, C, C++ or just traditional programmers, going into the realm of function blocks is like going from C-style structures and functions and into classes in C++. With function blocks, we can go from working in a procedural style programming into object-oriented style programming. I'll soon describe the main difference between these two programming paradigms. In this part of the tutorial, I won't cover object-oriented programming in too much detail as OOP is a subject in itself which requires a separate tutorial. I will only scratch on the surface of it. I will also not talk of whether procedural or object-oriented programming is better. So this won't be procedural versus object-oriented comparison. You can achieve very good maintainable, high quality and beautiful code with either of them, just as you can achieve really messy spaghetti code with both. I also want to mention that I initially thought that talking about OOP, function blocks and interfaces would fit inside one part, but that was a little naive. It's just too much to talk about, so I have decided to split it into two parts, 6a and 6b. This one being the first of them. This part will cover the basics of object-oriented programming and function blocks, while we in the next part will cover a slightly more advanced topic of interfaces. Within the computer science field, there are two major imperative programming paradigms, the procedural and object-oriented programming paradigms. In the previous part of this tutorial, we were using a procedural programming paradigm, also abbreviated POP. In POP, you have some global data defined, and then you have functions that act on those data. Every function can have its own set of local data. In the previous part of our tutorial, the global data was our event structure, and the function we wrote had some local data, which were some local variables to store intermediate data for calculation of the system time. In OOP, you have objects carrying their own set of data and their own attached methods. The objects can communicate with each other by so-called messages. In POP, importance is given to functions as well as sequence of actions to be done, while in OOP, importance is given to data. With POP, the program is divided into functions, while for object-oriented programming, the program is divided into objects. Now, what is an object? If we consider the real world, we find many objects around us. A table, a bicycle, or a cat. Or maybe more relevant for us in the industrial automation sector, an object might be a pneumatic cylinder, a temperature sensor, a camera, or a motor. All these objects have a state and a behavior, which define the object. Data define the state, and the behavior is shown via methods. One object can talk with another object by sending messages via its methods, either directly or indirectly, as we will look at later. We realize object-oriented programming and objects using what is called function blocks in IEC 61131-3. For any traditional software developers out there, this is the equivalent to classes. Function blocks can be seen as structures with attached functions, but instead of functions they are called methods. They can be seen as a blueprint from which an object is created. In this example, we might have an object that represents a motor, but it doesn't have to be a motor. You can represent whatever real-life object you want as one or several function blocks. It doesn't even have to be a real-life object. It can just be something imaginary like a database logger, a mathematical moving average calculation, or an object that takes care of events in the system. A motor is an object and could have several methods such as power enable, set speed, move to position, and many other. These methods describe the behavior of the motor. Next, the motor has data that describe its state. Examples of these can be power enable, to indicate whether the motor has power on or not, current velocity, temperature, and many others. Now the function block is only the blueprint of the object. To use the function block, we need to create an instance of the function block, in this case the fb_motor. A new instance of a function block is declared in the same way as on any other variable. You set a label on the variable, which will be the instance of the function block fb_motor, in this case fb_winch. This is the object. This object will have all the methods and data variables of the function block fb_motor. Now let's imagine we have a second motor in our machine that we're building. We can again just instantiate another instance of the FB motor. In this case, FB conveyor. Now we have two separate objects which we can use to both control the motors and see the state of them. What we have discussed is one of the fundamentals of object-oriented programming called encapsulation. The general idea of this mechanism is simple. If you have an attribute that is not visible from the outside of an object and bundle it with methods that provide read or write access to it, then you can hide specific information and control access to the internal state of the object. Now, why do we want to hide away the data in the function blocks and not just have all the data global? With the global data, we will end up with lots of unrelated bits of code that will become coupled to one another via the global variables. We'll most likely end up with spaghetti code, which is code that is hard to reason through and follow. It's hard to understand what is reading and writing to your variables and changing the state. Function blocks can have instance variables, that is, variables that are available for every instance of the function block. For motor, this could, for example, be whether the motor is powered on, its current position, and the temperature. Each and every instance of the function block will hold its own set of these variables. So let's imagine we first create one instance of the motor function block called FB winch. This might at one moment show that the power is on, the position is at 165.3 mm, and that the temperature is 32.3 degrees Celsius. Then we might have another instance of the motor function block for a conveyor belt, and this instance might at the same time show that the power is on, the position is 0, and the temperature is 26.7 degrees Celsius. Every instance of the function block will be its own object, representing the real-world object of a motor. A function block in TwinCAT 3 is created by right-clicking in POUs, selecting Add, and then clicking on POUs. This will show a new window. Write the name of the function block in the name text box. Next, make sure to select function block as the type. Click on Open. You have now successfully created an empty shell for a function block. Now, how do we access the internal state of the object, and how do we change that state? We do this through something called methods. Imagine we have the function block fb_motor. There are various ways we can change its state. We might have one method to change the position of the motor, or actually more precisely the axis that the motor is controlling. Then we might have another method to change the power state of the motor called power enable, which would take as input whether to power on or off the motor. Both of these methods change the state of the motor. Note that each and one of these methods might do a lot of things internally, but from a perspective of the user of this function block, that is not interesting. The user of the function block might just want to know how to power on the motor or change the speed. This is another pillar of object-oriented programming called abstraction. Each and one of these methods might internally do many things. Changing the speed might involve the call to several functions and function blocks internally, but the caller of this method doesn't need to know anything about the internals of this method. It only needs to know that it can power on and change the speed, not all the details on how this is actually accomplished. To create a method in TwinCAT, right-click on the function block in which you want to create a method in. Select Add, then select Method. Enter the name of the method and any eventual return type. The return type is not required. Select an access specifier, which we will get back to shortly. You have now created a method and you can now implement it. Now, to change the state of an object, there are other ways than just calling the methods. In structured text, it's possible to call the body of the function block directly. Going back to the motor function block, it means you could declare a function block header like this and instantiate it and call it like this, and still use methods at the same time. This looks very much like the functions we used in the previous part. The only difference is that the function blocks can store state over multiple PLC cycles in their local variables, while a function doesn't retain the state of the local variables between two different calls of it. This is one of the things that I always thought was a little weird coming from a traditional software development background, that is the possibility to call the body of the function block. For example, let's imagine we are doing Java. You can't instantiate an instance and then simply call. You can't do this in Java. All changes of state have to be done through methods. But we have to remember that a lot of the code we develop for PLCs is intended to be called cyclically, and here it actually makes a lot of sense to have some of the code in the body of the function block, while other code in methods. Now, when should you use the body of the function block and when should you use methods for changing the state of an instance of the function block? It's a little tricky to give general recommendations, and this is one of the topics that always create long discussions with lots of opinions. Many developers only use the body of the function block and others only use methods to change the state of an object. It's very hard to give general advice, but as much as I don't like to give general advice, I will still give you a general rule that I try to follow. And it's just somewhere in between these two extremes I just mentioned. I guess it's the Swede in me that just wants to be neutral and a little bit in the middle. We even have a word for it in Sweden called lagom. Anyway, I generally use the body of the function block for cyclical calls. In other words, calls that need to be made in every PLC cycle, and methods when they are a one-shot call for a request or message to change state. Again, this is just general advice and there are many exceptions to this. For example, for some very small function blocks, I don't even think it makes sense to have any methods at all, but it only makes sense to use the body of the function block. And as I will talk more about this in future episodes, you generally want to have very small function blocks that are doing one thing only, but that are doing this one thing very good. This is, however, a subject for a coming episode. Now I quickly mention inheritance. Inheritance is the procedure in which one function block inherits the attributes and methods of another function block. The function block whose properties and methods are inherited is known as the parent function block, and the function block that inherits the properties from the parent function block is the child function block. The interesting thing is, along with the inherited properties and methods, a child function block can have its own properties and methods. Inheritance is one of the pillars of object-oriented programming. Let's look at one example. Let's imagine we have a function block fb_notification that handles notifications to different users. The notification will have a few attributes such as an identity, the first and last name of the person to be notified, and a date and timestamp of when the notification was created. Now we can imagine that we want to send out notifications as an SMS. For this we can create a separate function block that only cares and handles about SMS notifications. This is still though a notification and it should have all the properties of a normal notification, such as the first and last name, etc., but with the addition of a phone number. The phone number is what is explicit only to SMS notifications. There is a relationship between the function block fb_SMS notification and the function block fb_notification. Now imagine we also want to send notifications by email. For this we would need a function block fb_email notification. It still has all the properties of a normal notification with the addition of an email address. By doing this we can have code that is shared and reused between various function blocks. Note that it's possible to do multiple levels of inheritance, but a function block can only inherit from exactly one function block. Let's now use an example that is slightly more related to the world of industrial automation and TwinCAT 3 software. Generally, when communicating with sensors and actuators, you need to communicate with the outside world by some means. When using Beckhoff PLCs, you generally use something called TwinCAT, which is like Ethernet on steroids. It's basically a deterministic version of Ethernet. I'm going to get back to this in much further details in part 10 of this tutorial, but for now you only need to know that every type of terminal to get sensor data or actuate something that you might want to communicate with has something called an TwinCAT slave controller inside of it, which is defined here by the function block fb_TwinCAT slave. Every TwinCAT slave will provide some basic diagnostics, which in this case is some info data which will provide whether the TwinCAT slave is operational. We can therefore provide a method is operational which just provides a single boolean of whether the ETCAT slave is operational or not. Now there are many different terminals depending on what type of sensors and actuators that you want to control. For example, we could have an 8-channel digital input terminal. This would be a function block FB_Beckhoff_EL1008, which is one type of terminals that Beckhoff provides. It provides its own special features as reading 8 digital booleans, which is indicated by the array with size 8. Because it inherits the function block FB_ETCAT slave, it also automatically has all the functionality of that function block, which means in this case it would have the isOperational method. And we could have many more type of function blocks that extend the FB_ETCAT slave function block. Here we have a 4-channel digital output terminal called EL2004. Instead of getting 8 input channels, we can now set 4 output channels. It too extends the FB_ETCAT slave function block, as it too has an ETCAT slave control and thus provides the isOperational status. Now I've used 2 Beckhoff terminals as examples, but it doesn't have to be a Beckhoff terminal. It can be anything that has an ETCAT slave controller inside of it. All of them will have the info data state variable, and each one of them will return whether the device is operational or not. We don't have to implement these specifics for each terminal that has an ETCAT slave controller, as each and one of them inherits the data fields and methods from the ETCAT slave controller function block. We'll get back to more details of field buses and ETCAT in episode 10 of this tutorial. To extend a function block, simply use the extends keyword. In this example, the function block FB_Beckhoff_EL1008 extends the function block FB_ETCAT slave. Now let's assume we have a program where we declare an instance of the function block FB_Beckhoff_EL1008. Because FB_Beckhoff_EL1008 extends the FB_ETCAT slave, we can do a call of the isOperational method on it, and thus make it return whether that particular terminal is operational or not. Used in the right places, inheritance can be very useful, but generally I would say it causes a lot of problems. It's a common misconception amongst beginners that inheritance is the true power of object-oriented programming. I don't want to dwell too much into the discussions of what parts of OOP is bad and good, especially in an introduction tutorial to TwinCAT 3. But I just want to mention that I've seen inheritance being so extremely overused, and where it has been used in so many places where it doesn't make any sense at all, and where there are better options available. I'll discuss this a little bit in the next part of this tutorial, but most likely I will leave this type of discussions to a future advanced PLC programming tutorial. Alright, so it's time to do a little bit of programming. Fun! And in this part we will continue to develop the event logger functionality that we did in the last part. And what we're going to do now is to create an event logger function block. And what we want this function block to do is to store all our created events. So once an event is added, the current system time will be added to this event, just like in the previous part of this tutorial. And the amount of events that we can store is a fixed size, and the amount will just grow until our buffer is full. So once the buffer is full, you can't add more events. And in this iteration, the event logger function block will be very limited in functionality. I just want you to get a little grip of creating a function block, some variables, and a method, or a couple of methods maybe. We'll see. And in this iteration, the functionality will be limited, and we will continue to develop this function block and the functionality around the function block in the next part of this tutorial, so that is in part 6b. Okay, so what I've done here is that I've opened the solution from the previous part of this tutorial, and what we're going to do first is to create a function block. So we do that here, and we name it FB_event logger. And this convention of adding FB_ is just a convention I always had. And actually, when I come to think about it, these conventions of adding FB_ or F_ or whatever that you add, it's mostly due to the history of PLC programming. It's more of the times when you didn't have actually very good integrated development environment, and you didn't immediately see what type of of data it was, or what type of, so you couldn't see if it was a function block or not, so you just added fb underscore. Nowadays, when using a modern development environment like Visual Studio for TwinCAT, it's actually not that useful anymore, I would say, because you're anyway going to see that it's a function block in several ways. So what I'm actually going to do now, so not to learn you the bad habits, is to remove fb and just call it event logger. So the name of the function block is event logger. You need to select function block here and make sure that the implementation language is structured text, because in this tutorial we will only do structured text. So select open. And now we have the shell for our function block event logger. And you can already immediately see here in FB, in here, that it is a function block actually. So the development environment already tells us that it's a function block. So this is very good. Okay, so do you remember that we had the structure here? This was the structure that defined our event, right? So we had the event type, the severity, the event identity, some event text, and a date and timestamp that we automatically created for using our system time. So this is what defines our event. And what we're going to do now is that we need a structure to store this and to store all of these events. So in our function block, we don't need any inputs or outputs. So what I usually do is I always remove the inputs and outputs until I eventually need them, because I just like to keep the code as clean as possible. So we need an array to store this data, all the structures. So right now I'm just going to create an array, and this is so let me just store it. Array with 100 of this structure as the event, right? So this is something I see quite often in code when I review other people's code or just code in general, open source projects. I see people naming an array like this, just array, and then they add a comment like this. This array stores our events and thus is our event buffer, or something like this. So they people name the array very badly, and then they add a comment to describe what the array is. And this is the thing with comments. I mean, this is maybe an extreme example, but comments are generally bad. I know a lot of people say, no, you should comment as much as possible, and that's just simply not true. This is what the software development world has evolved beyond this thing with comments. What you should do instead is to add very descriptive code. So you should focus on naming your stuff in the code and structuring your code in such a way that the code will be self-descriptive, right? Because what happens once you start adding comments, then you start to clutter it down, and eventually at some point or another the comment will not be right anymore. So it will describe something that's simply not true, because the code will change but the comments won't change. So and this is the thing, that the only thing that's worse than comments are comments that are just simply not right, that are comments that are wrong. So what I feel generally, if I try to use comments as little as possible, and if I ever use a comment, I know that I have generally failed. Okay, so I know that I've failed at modularizing the code to the certain extent it should be, and I really try to avoid this. So instead of adding a comment like this, and I just want to point out here that this is general comments, right? So there's of course exceptions to this where it's actually not a comment anymore. But if you write documentation, general documentation about what a function block should do, I mean something like this, that's fine. Or if you do an API, okay, so you're going to do code that other people are going to use, they're just going to make an API call a method or something, then it makes total sense to use comments or API descriptions that describe what the API is. But in this case, for example, I would just name it event buffer. Oh, okay, we don't actually, that's enough, event buffer. So there's a naming convention, array start with A. You don't need this. Again, we can just call it event buffer. Okay. And here is the next thing, right? So you have 100. That's a number. I kind of know it's the max now, so that's the maximum size. But here is also an opportunity to even add more documentation to the code. So I would just create a constant So constants are variables that cannot be changed and during runtime. So I would just call it constant maximum size of event buffer, something like this, an integer, and assign it the value 100, and then use that instead, right? And then I can just skip this comment. And I think this code is just much better now. It explains exactly what it's doing. So I think I'm getting a little off track here, but this is again something I kind of like to tell people that are starting with software development, that just don't try to, creating all these non-descriptive variables and then just using lots of comments to explain what's happening, because that's just gonna end up with disaster, especially once just refactor it in that case. Okay, so what we're gonna do now is to add our method that will where we can add an event to this function block. So again, now we have this buffer which holds all our events in this function block. So what I'm gonna do is right click on the event logger function block, click add, then method. And here we have to give the method a name. So I would just call it add or add event. But because it is a function block that's called event logger, we can assume it's an event. So we only need add. And the return type, we can actually give a return type. For example, we could indicate whether the addition was successful. Maybe our buffer is full, and that's one way that this could not be successful. So we could actually return a bool. Then we need to select structured text and add an access specifier. An access specifier is something I haven't mentioned, so I guess now is a good opportunity for that. Now I'll briefly talk about access modifiers. When you declare a method inside a function block, you have to set one of 4 access modifiers. With public, everyone has access to the method. This means that the function block itself has access to it, as well as anyone else outside of the instance of the function block. So if you would instantiate a function block x with method y and instantiate the function block z, then function block z could call y. With private, only the function block of where the method is declared has access to the method. With protected, only the function block of where the method is declared and any of its children have access to the method. With children, I mean any function block that extends the function block that has the protected method. With the access specifier of internal, only the function block of where the method is declared and any function blocks that reside in the same library have access to the method. I'm not going to talk too much about libraries right here and right now. Instead, I ask you of some patience, as we will come back to libraries in part 11 of this tutorial. Okay, so we'll select the access specifier of public, because we want this method to be able to call it outside of the function block. So we want to be able to instantiate the event logger function block and from another function block maybe, or from the main program or whatever, and then be able to call this method add. So it has to be public. Okay. Okay, interesting. It's not possible to create a method called add for some reason. Interesting. Okay, so we just call it add event. It's probably a reserved word in the ISC standard for methods. Right, so now we have our add event, which returns a bool. And again, now this bool, someone that's calling this method might not know what is this bool? Why does this method return a bool? So here, this is an API type of call, so now it actually makes sense to add a comment. Returns true if add was successful, and false if buffer is full, for example, or just false if it was not successful. So now the caller, the user of this function block, will actually know what this boolean is. Okay, so what we're going to add now is we need some input variables, and this is, we could just use this whole structure, but that's a little confusing because then the caller has to provide the date date and timestamp, which we don't want, because the date and timestamp, we want that to be added automatically in the function block. So once the user adds this, adds this event, we just want the function block to automatically create this system timestamp and add it internally. So we want to add everything except this one. So we can just copy and paste these variables and add them as input variables. So the user needs to provide the event type, the event severity, identity, and text, but not the timestamp, because we want to create the timestamp here internally ourselves. So the user doesn't have to care about that. Okay. So now if we're gonna add an event, we need to know whether our event buffer is full or not. So we need to keep track of how many events we already have in the system. So in our function block event logger, we need to add a variable that keeps track of this. So we will call it event buffer entry or index, and buffer index. And it's just going to be an integer. Okay. And this starts at 0, so it means that when we add our first event, this will go up to 1, and then we're gonna store the first event at location 1 in this array, and up to 2, and then to 3, all the way up to 100. This buffer index will go. Okay, so what we need to do first is to check whether the event buffer is full, right? So we have to check whether the current location of where we are at is above 100. So we need to check if this current event buffer index plus 1, because it's the next one, right? Because if we are at 100, then we want to check if we are at 100, if the next one will be at 101, which will be too big. So if this is larger than the maximum size, which is 100, so we use our constant, we can reuse the constant here. So this method here has access to all the constants and all the variables in this function block. Then we're full, right? So we don't want to add any new events here, so we're full. But what I thought about right now is actually that, I mean, this is kind of self-describing. If you read the code, but you can actually make this even better by adding another private method that just does this. So again, I like to modularize my code as much as possible. I want my code to be self-descriptive as much as possible. I just want it to have this clean and nice feeling of just explaining everything, what's happening. Just as I keep my apartment clean, I want my code to be really clean. And this is something that pays off for sure, especially if you're many people in a project, or if someone else is going to maintain your code further. I mean, a couple of years down the line, just try to be as descriptive as possible. So what we'll do is just to add a private method that returns whether the buffer is full or not. And this method can be private because there's actually no one else outside of this function block that needs to access it. I mean, the add event needs to be public because that's how someone adds an event, by calling it. By private, we only need to do it here internally in this function block. So we call this is event buffer full, which is a very good and a scripted name. The method tells everything we need to know. Is the event buffer full or not? So it just returns a boolean, and it can be private. It doesn't have any input, and it only returns a boolean. And we actually don't even need to comment this API or this return value, because the method name tells us everything we need to know. And again, going back to this, giving good names to variables and methods and functions, it's just really, really good because you don't need to comment as much then. Okay, and this we moved this code that we did in add event to this is event buffer full. And the only thing that this method has to do is return whether the buffer is full or not. So if the current index plus the next one, the one we're going to add, is larger than the maximum size, then yeah, the event buffer is full, right? So it will return true. And the way we return a value from a method is just like with a function, that you just use the name of the method and assign the name of the method the value. So this boolean is this, and this is this. Okay, it's full, else it's not full. Okay, so now we have a neat little function that we can call in our add event. So here we can now call if not is event buffer full. So if our event buffer isn't full, then we want to add an event, right? So this is really neat. Now our code is just much more self-descriptive, and yeah, I'm pushing on this a lot, but I just really don't want you to go into the rabbit hole of using, or the path of using comments and just using all these bad variable names instead of splitting the code up into this. It just looks so much better, and it's just so much more enjoyable to look at. And I mean, I've done so much code reviews in my life and everything that I kind of just get the eyes for this. And I mean, I'm not an angel. I make a lot of mistakes as well, and when I'm stressed, I name variables. I give really bad names to variables, but then I'm always ashamed of it. And yeah. Okay, so here, if the event buffer is not full, we can add our event. Here we will write some code soon. But if it is full, then we just want to return add event equals to false, right? Because we return false if the buffer is full. So we already know what we're going to do. We just return false if it is full. If it's not full, then we will return true, because it's not, oops, true. And now we're going to add our event. So what we're going to do is to, in this event buffer, we're going to add our event in the location of where we are currently, +1. So we can already increment this current event buffer index by 1, because we're going to go to the new location. So if we start at 0, we want to go to number 1, which is the first one, all the way up to 100. Okay. Then we want to store it in this location. And we want to store, first we want to store the event type. So again, this is just a structure, an array structure. So we store the event type, then we store the next one is the event severity, and we store the event severity. Next one is event identity, and this is the event identity that we provide, and the event text. Like this. Okay, but we also have in this buffer, in this event structure buffer, we have our timestamp, right? So we needed to store that as well. Okay, to add our date and timestamp, we're going to use our update event timestamp with system time function that we wrote in the last part. And what it does, it takes the whole event structure as input. So you could argue that you could have, for example, another function here that would just return the system time or as a date and timestamp instead. But this is how we did it in the last part of the tutorial, and we will reuse this function, which makes a lot of sense. So what we need to provide, we need to do a call of this update event timestamp with system time function. It's a very long name. And we need to provide it an st event. Okay, and the st event here, that is the current event buffer structure where we are right now. So it's this one, because this one is the whole structure, right? The event buffer is an array of events. So we just need to provide the current location where we are right now, like this. Okay. So this will take this function will take a reference to this buffer location of this structure, and just only update. I mean, if you look at this function, it will only update the date and timestamp of this event. So that's pretty much everything we need to do. And this is, I mean, there's lots of limitations, of course. I mean, when the buffer is full, we're just going to end up here and we're not going to do anything with the event. You could argue that, for example, maybe we want the oldest event to be removed from the queue. So we could create a queue of some sort, and maybe we want it to be a linked list so we can remove an event in the middle. But I mean, we could spend lots of time showing you this, but again, I want to save a little bit of the fun for the next part of this tutorial. So what we need to do now is to use this function block and see that it's actually working. So what we're going to do is that in main, we are going to, we can remove this code or just comment it. This is from the last part of this tutorial, the previous part. So we can just do like this so far. And what we're going to do now is to create an instance of this function block event logger. And you create an instance just like any other variable. So if you create an instance of a function block just like if you would create an integer or a boolean or whatever. So it will reserve the memory in the PLC for this instance of this function block, and we can just call the instance. We can actually call it the same name as the function block. So we have an instance of event logger, and now we can also try to add an event to it just to see that it works. So here in main, we can just create some variables that are necessary to add an event. So that is these guys. And we can just set some values to them. The event type could be alarm, and severity could be error. Event identity could be 42, and event text, this is a scary event. Oh, I forgot this guy. And what we want to do is to add this to an event given some criteria. So we can just say that we can have a boolean. So we take this boolean back, and if this boolean is true, then we add this to the event logger. So if be boolean, then here we will add the event. Then we have to make sure to set the boolean to false as well. So we will use the oops, what happened? Sorry. Event logger, add event, and then we have our event type, then we have our event severity. I mean, it's this one, and the event text. I mean, we can just call this something one just to really show that this is just an instance like this, and this. And we need to make sure that this is set to false. So which means that when we log into the PLC, this will be false initially. If you set this to true, then we will add the event in one cycle and then set this one to true, so to false. So we don't set this in every cycle of the PLC. And then we can log into the event logger, this instance of this function block, and actually see that we have that event has been added. I mean, here we can have many event logger. We can have event logger 2 that is also an event logger 3, and so forth. Again, this is a function block, and it's just like any other variable. We can create as many instances of it as we want. And for the event logger, it typically makes sense to only have one, right? Because you want to have a global event logger for the whole system of some sort. But I mean, this is one example of a function block. You can have, as I mentioned in the PowerPoints, you could have motors or maybe temperature sensors or whatever, in where you would normally have many instances. Okay, I guess it's time to run this. So we will activate configuration. Yes, we want to go in run mode. Exciting, always as exciting. Super exciting to start TwinCAT every time. I never get tired of it. Yeah, just kidding. It's not that exciting actually. Anyway, yes. And okay, and execute. So now we're running runtime, and our binary is being executed. But we haven't added event because the boolean is false. And what you can actually do in this online views, you can log into the event logger, and here you can actually see, the constant, but you can also see the index we are at now, 0, because we don't have any events added, and the event buffer. So here, if you go in, this is our array with our events, and now all of them just have the default values because they're empty. They don't have any events. So what we're gonna do now is to change this boolean to true and do an online write, and then we will get an event added with the values that we prepared in main, which were these, right? So let's just do our write values. Okay, now we go to the event logger. Now this incremented to 1, which means that the first one should hopefully have our event, which it does. And it also has the system time timestamp in it. So it worked. Okay, so that's about it for now, what I'm going to show you. I mean, it's not so much functionality. You will just have to wait until the next part, where we'll add some more functionality around this function block in regards with this thing called interfaces. And that's it for this part. We have only scraped the surface of the capabilities of function blocks and object-oriented programming in TwinCAT 3. This part was supposed to also cover interfaces, but I realized quite quickly that it was just too much information. And that's why you have to wait for the next part to learn about interfaces. See you in the next video.